Then the next definition you can write down is another set of scientists, Lowry and Bronsted, who came together and came up with a different definition of what an acid and a base is. Okay, and their definition is this one here. So Lowry and Bronsted together said that, just as you saw from your live worksheets, that an acid is something that donates a proton, in other words, a hydrogen ion, and a base is something that accepts a hydrogen ion. Now, you did a whole worksheet, you're welcome to write this down. You did a whole worksheet or part of a worksheet where you just used Lowry Bronstet's theory and figured out which substance was an acid and which one's a base. But we're going to go over that again now. We're going to look at that live worksheet and we're going to identify and figure out exactly which ones are acids and bases. So take a moment and write that down. Then we are going to go to that live worksheet 3 and we are actually going to practice those acid and identifying which is the acid and which is the base. Okay, so you probably have taken notes as you did that live worksheet, but we're going to do a quick little recap. So the first thing talks about the scientists, Lowry and Bronsted, talks about their theory again, and then it tells you basically when they talk about a proton, the fact that an acid is something that donates a proton and a base is something that accepts a proton, what they mean by that. If you look at a hydrogen ion looks like this. It has one proton and one electron in it. Now, sorry, not a hydrogen ion, a hydrogen atom. Now, when that hydrogen atom loses its electron, it becomes H plus 1, becomes a hydrogen ion. Now, essentially what happens then is all that's left over in that acid, that original atom, is a proton. So when they say an acid is an atom and an acid is a proton donor and a base is a proton acceptor, what they're talking about is this. An acid is a hydrogen donor, a hydrogen ion donor rather, and a base is a hydrogen ion acceptor. So what does that mean practically? So let's look at some of these examples that you had in your live worksheets. Okay, starting with the first one here. So you had hydrochloric acid dissolving in water and becoming hydronium ions and Cl minus. So this is actually very similar to the one we did when we did the definition of a strong acid. Now your first job is to identify which ones are pairs. So they're actually not difficult. HCl will become Cl, so that's a pair, and then H2O will become H3O, that's a pair. Now let's write the little definition here. Acids are things that give off or give away a hydrogen ion, and bases are things that gain a hydrogen ion. So let's keep that in mind as we go through this. So if you look at this reaction and you read it, you can see the double arrows. Don't worry about the top arrow pointing back and the forward. It's just the way that the Word document does it. It makes no difference, okay? HCl to become Cl. Ask yourself, what would HCl have to do to become Cl minus? It would either have to gain or lose a hydrogen. Now, HCl to become Cl would have to literally give away a hydrogen. And things that give away hydrogens are called acids. So I'm going to call this acid number 1. Then if you look at the Cl's perspective and you read the reaction backwards, for Cl to become HCl, Cl would have to gain a hydrogen and therefore become HCl. When Cl gains a hydrogen, it acts as a base, and so we call it base number 1. So this is our first pair, acid 1, base 1, they're a pair. Now let's look at the water. For water to become H3O plus, you have to ask yourself, what did the water do? Not the H3O plus, the water. You're reading it from left to right first. For the water to become H3O plus would have to gain a hydrogen. And if it gains a hydrogen, that means, if you look at your definition, something that gains a hydrogen is a base. So we call this base 2 because it's now the second pair. Then H3O plus, if we read it in reverse. Now, the base should form the acid, so it should just be like that, but we want to try and make sure we understand that. So H3O plus, if we read it in reverse, this to become this, H2O, H3O plus would have to give away a hydrogen to become water. So that makes H3O plus an acid. Okay, so that's your first example that was in the notes. Okay, then moving on to the second one. Okay, so an acid, I'm going to write this for myself every time, gives away a hydrogen ion, and a base accepts a hydrogen ion. Okay, so let's look at that. This one's done for us, but let's see if we understand this. So the first thing is NH4 plus. This is ammonium, right? Ammonium, okay, and it's easy to see the pair is the NH3. Ammonium to become NH3. The ammonium would have to give away a hydrogen, give away or let go of a hydrogen. So that makes it acid number 1. Acids give away hydrogen. Now that should form base 1, but we're just checking. If you read this in reverse and you read ammonia to become ammonium, this NH3 would have to gain a hydrogen to become this, so that makes it a base. Now let's look at the second pair. CO3 2 minus to become HCO3 1 minus. CO3 2 minus would have to gain a hydrogen, making it a base, and that becomes the acid. But let's double check. HCO3, if you read it in reverse, HCO3 to become CO3 would have to lose a hydrogen. So losing hydrogen are things that acids do. Okay, so as we go, I know you did this on the live worksheets. If you didn't write this in your book, write it in your book now, so that when you study for your acids and bases test, eventually you have one place with all your notes in it. Okay, let's go on to the next one. So water will obviously become OH, so it's not too tricky to see that. Okay, so water, to become OH minus, water would have to give away a hydrogen. Let's write this here. Acids are things that give off, and I don't think you can ever write this enough to remind yourself. Acids will have to give off hydrogen. So if it gives off a hydrogen, this is an acid, and then that would form your base 1. Now let's look at the next one. Ammonia to become ammonium. This has got 3 hydrogens in it. This has got 4. If this substance wants to turn into that substance, it'll need to gain another hydrogen, which makes the NH3 something that needs to gain hydrogen, so that makes it the base 2. And that will form acid 2. Okay, let's go on to the next one. HCl and Cl are obviously a pair, and ammonia and ammonium are a pair. Okay, so forget about the fact that you know HCl is an acid and really think it through and work it out. So HCl to become Cl would have to give away that hydrogen. When it gives away that hydrogen, it's an acid, and that forms your base. Now, this doesn't have to be pair 1. For the purpose of the live worksheets, we said always make the first substance number 1, the pair 1. You don't have to do that. This could have been pair 2. It doesn't really matter. As long as the correct substances are joined together, it doesn't matter which one you make pair 1 and pair 2. Then NH3 to become NH4. What would NH3 have to do to become NH4? It would have to gain a hydrogen, right? So if this thing needs to gain a hydrogen, it makes it a base, and that makes this one the acid. Okay, I'm going to keep writing this every time we have to go into a new page. Then C. CO3 minus, and that one would obviously be a pair, and water and OH would be a pair. So if you read CO3 2 minus to become HCO3 minus, this will have to gain a hydrogen, so that makes this a base. Then this will become acid 1. But let's double check. HCO3 to become CO3, this will have to give off a hydrogen. So to give off a hydrogen, that makes it an acid. So we were correct there. Okay, then H2O to become OH minus would have to give off a hydrogen. And when something gives off a hydrogen, it makes it an acid. And then this will become the base pair. So these are called conjugate acid-base pairs. Okay, now I actually want to write something down while we're at this. So if I am asked to figure out something's acid or base pair, let's erase all of this and write that down. So let's look at the reaction we just did, for example. Well, let's look at both of these. If they said to me, write the conjugate base of HCl down, then I would go, okay, if I'm looking for the conjugate base, that must make this substance the acid. And acids are things that, let's write this again, that give away hydrogen ions. So acids are things that give away hydrogen ions. So HCl will give away a hydrogen ion and become Cl. Now let's talk about the charges for a second. HCl is neutral, okay? It doesn't have a charge. It's just a proper normal neutral compound. Hydrogen has a charge of +1. So when something gives away or gives off a hydrogen, hydrogen is +1. Therefore, the substance needs to lose a +1, or it needs to become one more negative. So if it used to be neutral and then it gives away its +1, the remaining substance needs to be -1. Or you could have gone 0 minus 1, which is -1. Then let's look at NH3. If they tell you in a test that you need to write down the conjugate acid, what that means is if you want the conjugate acid, this must make the substance in front of you the base. And what do bases do? They gain hydrogen ions. So that would be quite easy. N, it used to be 3, now it's 4. But now let's look at the charge. Now this used to be completely neutral. When something gains a hydrogen, and a hydrogen has got a charge of +1 again. So when something gains a hydrogen, it needs to get a +1 charge. So this becomes +1. Or you could go 0 +1, which gives me +1. Let's do that exact same thing with the second reaction here. So let's say they asked me for the conjugate acid of CO3 2-. Now, if I want the conjugate acid, that must mean that this substance is the base. Now, if that's the base, what do bases do? Bases gain hydrogen. Okay, so if it gains a hydrogen, it needs to become HCO3. Now let's look at the charge. When you get a hydrogen, hydrogen's got a charge of +1. Then your existing charge, which at the moment is not neutral, but in fact -2, needs to add a 1 to it. Okay, you can write that minus in front if you prefer, if that looks easier to you. Okay, so that -2 charge needs to become one more positive. So it becomes -1. So now the charge on that substance is -1 instead of -2. Okay, let's look at the next one. Let's do it at the bottom here. If they told you, give them the conjugate base of water, that must make water an acid. And acids are things that give away hydrogen. And if this gives away hydrogen, you could easily think you need to write HO. Okay, but we know that we don't write it like that. We write OH for hydroxide. Now let's figure out the charge. Now this used to be neutral. When something gives away a hydrogen and gives away a +1, it needs to become one more negative. So it used to be neutral, now it needs to become one more negative, so the charge is -1. Okay, so let's keep that in mind. Okay, then going on to question D. I'll just give you a second to write that down. Okay, going on to substance D, let's just erase all this so we have a bit of space. Okay, so substance D, HCl becoming Cl, and NH3 becoming NH4+. So HCl, in order to become Cl, will have to give away a hydrogen that makes it an acid, and this forms the base. NH3 to become NH4, NH3 would have to gain a hydrogen, which makes it a base,